Hi everyone, welcome to MathWorld. This is Cambridge International AS and A-Level Mathematics Paper 5, which is a Probability and Statistics 1 for October-November 2023, and the code is 9709/52. So let's move on to question number 1. Okay, so for question number 1, a competitor in throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceed 30 meters. The probability distribution table for x is shown below. So this is the probability distribution. Now A, given that Ex equals to 1.1, the Ex here is the expected value of the x. Find the value of P and the value of R. So first of all, we know that total probabilities equals to 1. Okay, that means 0.4 plus P plus R plus 0.15 equals to 1. So from here, we will be getting P plus R equals to 0.45. Okay, after you have moved the 0.4 and 0.15 to the right side and simplify with the 1. Okay, then now use the given Ex value. So Ex equals to 1.1. Ex is summation x times probability. That equals to 1.1. That means you need to multiply x with the probability. So which means now I will be getting 0 times 0.4 plus 1 times P plus 2 times R plus 3 times 0.15. Then the answer is 1.1. Okay, so from here, the first term will be 0. This is 0. Then I will be getting P plus 2R plus 0.45 equals to 1.1. Then from here, once I have simplified, I will be getting P plus 2R equals to 0.65. Then I will let the previous P plus R equals to 0.45 be the first equation, and this is my second equation. Now to solve the P and R, I will be using the elimination method. That means second equation minus first equation. Okay, so P minus P will be 0, 2R minus R will be 1R, then 0.65 minus 0.45, it will be 0.2. So once we have found the R, you can just find the P using first or second equation. So here I will use first equation. So from first equation, my P is 0.45 minus R. Okay, you can just move the R to the other side. Then replace the R by 0.2. Then I will be getting P equals to 0.25. So that is my P value. Okay, now part B, find the numerical value for variance x. So we need to get the Ex squared first. Ex squared is summation x times P, x squared times P. Okay, so use back this form. Then just square all the x here. Alright, so the first term I will ignore because it will be always 0. Then I will write 1 square times P plus 2 square times R times plus 3 square times 0.15. And now replace the R by 0.2 and P by 0.25. So here you will be getting 0.25 plus 2 square is 4. Then the R is replaced by 0.2. Then plus 9 times 0.15. Then at last, your Ex squared will be 2.4. Okay, and now to get the variance x is basically Ex squared minus square of the Ex. Then here I will be getting 2.4 minus Ex is given in the question, which is 1.1. So I square the 1.1. So here minus 1.1 squared. Then at last you will be getting 1.19. So that is the solution for part B. Okay, now for question number 2, George has a fair 5-sided spinner with sides labeled 1 until 5. He spins the spinner and notes the number on the side on which the spinner lands. A. Find the probability that it takes less than 7 spins for George to obtain a 5. Okay, so now from here, the probability, let's say, is P equals to P less or X equals to 5 to obtain a 5 is basically 1 out of 5 because it's mentioned fair spinner. So 1 over 5. And then to get this, basically this is geometric progression. So which means now our Q is 1 minus P, which is 1 minus 1.5. Then I will be getting 4 over 5. Okay, so since this is X equals to geometric, okay, my X is the 5. That means now I will let my Y be the spins. How many spins, right? So it will be 1 over 5 here. So now you need to calculate the probability that it takes less than 7 spins to get a 5, right? To get the first 5. So that means P, Y less than 7. So now for the geometric progression, we have a formula. If it is X equals to geometric progression, geometric distributed with probability of success P, Px less equals to R, it will be 1 minus Q to the power of R. Okay, whereby the Q is 1 minus B. So from here, to make it to less than equal sign, I have to change to less than equals to 6 because Y less than 7 means it is from 1 until 6. So I will say that it is same as P, Y less than equals to 6. So when you compare with this general formula, the R becomes 6 now. Therefore, it is 1 minus Q to the power 6. Then at last, I will be getting 1 minus 4 over 5 to the power of 6. Okay, then at last, you will be getting the probability of 0.738. So that is the solution for 2A. Okay, now for the B, George spins the spinner 10 times. Find the probability that he obtains a 5. Okay, same number. Means the probability is still 1 over 5. And then now spin 10 times. Okay, the probability of obtaining a 5 more than 4 times but less than 8 times. Obviously, this is binomial. Okay, so here I will write your Y is binomial. The N is 10. Then the P is 1 over 5. Then from here, you need to count probability that he obtains more than 4 times. So more than 4 times, but less than 8 times. Okay, so then from here, I will say that it is Y equals to 5 because it's more than 4. So it will be 5, 6 plus P Y equals to 7 because it's less than 8. Alright, so now we use the binomial distribution formula, which is X is B and P. Your probability of X equals to R equals to NCR, PR, Q, and minus R. Alright, so from here, I will be getting 10C5. The P is 1 over 5. 5 successes. Failures will be another 5 because you consider 10 spins. Then plus 10C6. Then 1 over 5 to the power 6. Then 4 over 5 to the power 4. Okay, plus 10C7. Then 1 over 5 to the power of 7. 4 over 5 to the power of 3. Then at last, okay, so if you count all this separately, if you will be getting 0.026424. I give more decimal places here as the working. Then this is the next value, and the last value is 0.0007864. Okay, and now final answer, I will round up to 3 significant figures. That will be 0.0327. So that's the probability in part B. Okay, now next question, number 3. A factory produces a certain type of electrical component. It is known that 15% of the components produced are faulty. A random sample of 200 components is selected. Use an approximation to find the probability that more than 40 of these components are 40. So now your n is 200. Okay, the p is 15%, that means it's 0.15. Then from here, I know that the q is 1 minus 0.15, which is 0.85. Okay, so it's mentioned approximation. Initially, it was binomial distributed because the component will be discrete random variable. So now, since it's mentioned approximation, so now I check the NP first. So the NP is 200 times 0.15, then you will be getting 30, which is greater than 5. Now the NPQ, it will be 30 times 0.85. And then you will be getting 25.5, and again this is more than 5. Then from here I know that when the x is binomial distributed with n 200, then the p is 0.15. Then now it will be approximated to normal distribution with the mean of 30 and the variance of 25.5. Okay, now you need to count the probability that more than 40 of the components. So which means you need to count px greater than 40. Now you must be careful because your x is binomial distributed, your w is normally distributed. So therefore we have to consider the continuity correction because your binomial is discrete random variable and your x is discrete random variable and the w is continuous random variable. So when x is greater than 40, it will be 41, 42, and so on. So then we have to plus minus 0.5 from the 40. Okay, so here either you minus 0.5 from 40 to get 39.5, or you plus 0.5 from 40 to get 40.5. So now you change your x to w, remain the inequality sign which is greater than. Now the 40, you have to decide whether it is 39.5 or 40.5. So obviously it is greater than. Okay, here is greater than, therefore your region should be towards right side. So obviously from this number line you have to choose 40.5 so that it will include the two ticks. Right, so now once you have changed to w, therefore this is normally distributed. So according to the formula, x is normally distributed with mean mu variance sigma squared. We need to standardize it first before you use the table in the formula list. So you have to find the z, which is equal to x minus mu over sigma. So now I will get pz more than 40.5 minus my mean is 30, then over this is variance. That means 25.5 is variance. So to get the standard deviation, you have to take square root. Alright, so that means here you will be getting probability of z more than 2.079. Right, so now once you have obtained this step or this probability, okay, or this expression, you need to draw the graph or sketch a graph. So mark this 2.079, which is on the right side, and since it is greater than, therefore the region is towards right side. Okay, so now if you refer to the table, the region is always towards left side, right? So obviously it should be 1 minus pz less than this value, less than the arrow to the left side, then you will be getting the shaded region. So which means it should be 1 minus p z less than 2.079. Then from here you read the probability from the table, and the answer, the value will be 0.9812. Okay, so once you have minus or you have solved this operation, you will be getting 0.0188. So that is the solution of this question. Okay, now next question number 4. The heights in centimeter of the 11 players in each of two teams, the Aces and the Jets, are shown in the following table. So these are the heights. Now A, draw a back-to-back stem and leaf diagram to represent this information with the Aces on the left hand side of the diagram. Okay, so now they are not all arranged in order, so just have a quick inspection. The smallest value for aces will be 164. Okay, then the highest value for aces will be 182. Right, and then the smallest value for jets will be 166, and the highest value is 190. Alright, so now for the stem and leaf, back-to-back stem and leaf diagram, I will start with 16 first, then aces on the left side, jets on the right side. Okay, so now okay, so smallest is 164, 166, that means it's 16, then 17, 18, 19, because highest is 190. So now for the aces, okay, so smallest 164, so 164. After that 166, 168, 169. So 689, so 6, 8, 9. After that 171, then 73, 74. So 1, 3, 4. After that you will have 180, 181, 182, 182. So 0, 1, 2, 2. Alright, so now for jets 166, then after that 168. That's all for 16. So 170, then 74, 74, 75. So 0, 4, 4, 5. Okay, after that 18, 181, 181, then 186, 188, 188. So it means that 1188. Then lastly 190. Okay, so this will be the back-to-back stem and leaf diagram. Do not forget about the key. So let's say I take this value. Alright, so let's say I take this. You can take any values. So it will be 0 slash 18 slash 1. So this means 180 centimeters for aces player. 180 centimeter for aces player. Okay, then another one is 181 centimeter for jets player. Okay, so that's the full solution of this stem and leaf, back-to-back stem and leaf diagram. Okay, part B, find the median and interquartile range for the heights of the players in the aces. So median, okay, now let's check. Initially you have 11 players in each team. So now median is basically half of n plus 1 theta. Okay, that means now the n is 11. So that means the median is the theta number 6. So now when you look at the theta here, this is theta 1, 2, 3, 4, 5, 6. That means this is your median. So the height is 173 centimeter. So I will write here 173 centimeter. Okay, so done for the median. Now interquartile range, we need to find Q1. So Q1 you can just divide equally because we know that the median is 6. So then now it will be 5 on the left and 5 on the right. So now if you take the middle of the 5 theta, it will be the number 3. Okay, because 2 to the left and then 2 to the right. So obviously this is your Q1. So I will get 168. Then for Q3, same method, right? So now here I will have 5. This is 1, 2, 3, 4, and 5. Okay, so 5, the top 5 data. So again, when you divide, so it will be 4 and 5 together, then 1 and 2 together. So now obviously the Q3 is 182. Okay, so this is 182 centimeter. Okay, let me check. Alright, so 182 centimeter. So now your IQR, interquartile range. So interquartile range, Q3 minus Q1. Okay, that is the calculation. Then you will get 182 minus 168. So here I write cm. Then you will be getting 14 cm. Okay, so that's the solution of this question. Alright, C. Give one comment comparing the spread of the heights of the aces with the spread of the heights of the jets. Alright, so spread is basically the width. Is this the range, okay, or variability. So from here, I would say that for the jets spread, okay, so it will be the highest value minus the smallest value. So highest value for jets is 190, smallest is 166. So 190 minus 166. Then you will be getting 24 centimeter. Now for aces, right, so it will be highest 182 here and lowest 164. So 182 centimeter minus 164 centimeter. So at last you are getting 18 centimeter. So from here, obviously, the jet's spread is greater than aces spread. Okay, so my comment is jets. This is comment. Jets players heights has greater spread than aces players. Okay, or here if you don't write spread, you can just write range. It's the same. Okay, so that's the solution for part C. Now for question number 5. The heights of the members of a club are normally distributed with mean 166 cm and standard deviation 10 cm. So here our x is normally distributed, 166 is the mean, variance is 10 squared because standard deviation is 10. Then find the probability that a randomly chosen member of the club has height less than 170 centimeter. So px less than 170. So this is normal distribution. We standardize it first. And then this is going to be pz less than 0.4. Okay, so when I sketch a graph, bell-shaped curve, and mark 0.4, draw a line at 0.4, then since it is z less than, that means the region is towards left side. So this region you can just direct read from the table. It is 0.6554, and now when you round up the value to 3 significant figures, it's going to be 0.655. Okay, so done for A first part. Now, second part, given 40% of the members have heights greater than h centimeter, find the value of h correct to 2 decimal places. So now I will rewrite my x is normally distributed, mean 166, variance 10 squared. Okay, greater than h centimeter. So px greater than h, and it is 40%. That means it's 0.4. Okay, so from here I will standardize it first. So you get h minus 166 over 10. Okay, that is my z value, and the probability is 0.4. Now, once you have standardized, sketch a graph. Middle value is 0. Okay, so now for your information to decide where is this whole line. Okay, so for your information, the graph is symmetrical at origin. Therefore, PZ more than 0 is 0.5, because the total region under the curve is 1. The total area of the region under the curve is 1. Okay, but then when you look at when you compare these two expressions, both also z more than, right? Because the region here, if it is exactly 0 for the line, you get 0.5, but then now it is only 0.4. So obviously the line is on the right side. So here is 0.4. Okay, so I will label h minus 166 over 10 for the line. So then from here, obviously, the region towards left side will be 0.6. Okay, so now I will write this down first. So PZ less than h minus 166 over 10 equals to 0.6. So then, since you have found the region towards left side, then we can just get it from table. So from table, PZ less than 0.253, it will be 0.6. Okay, then from now I will just compare. h minus 166 over 10 equals to 0.253. Right, so from here, the h is going to be 10 times 0.253 plus 166. Then this is going to be 168.53. So that is the h. This is the exact value, okay? And it's mentioned correct to 2 decimal places. So that is the h value. Okay, now next question B. The random variable x is normally distributed with mean, mu, standard deviation, sigma. Given that sigma is 2 over 3 mu, find the probability that a randomly chosen value of x is positive. Okay, now x is normally distributed, mean, mu, variance, sigma squared. Okay, and given sigma is 2 over 3 mu. So from here, I will say that my mu is basically 3 over 2 sigma. You can keep your sigma, or you can just change the mu. Alright, so now you need to find the probability that x is positive. Positive means greater than 0. Then I will standardize it. Z more than 0 minus mu over sigma, and now the mu will be replaced. So then I will get PZ more than minus 3 over 2 sigma over sigma. Okay, then now obviously the sigma can be cancelled off. Then I will just need to calculate the probability that z is greater than negative 3 over 2, which is negative 1.5. So now I will sketch a graph. Here is negative 1.5, and greater than negative 1.5 means that is the major region. And now I'm going to reflect. Okay, I draw another graph. because the z value is negative, so it's not available in the table. So once I flip it in the line y, the 0, that means it will be 1.5. Okay, and now when I flip the region, it will be the major region, which is towards the left side. So obviously from here, I will get equals to pz less than 1.5. And now I can easily read this probability from the table. So it will give you 0.9332. And when you round up to 3 significant figures, that is going to be 0.932. So that's all for this solution. So now, question number 6. Freddy has 2 bags of marbles. Bag X contains 7 red marbles and 3 blue marbles. Bag Y contains 4 red and 1 blue marble. So 2 bags here. Round 9. Now, Freddy chooses one of the bags at random. A marble is removed at random from the bag and not replaced. Okay. A new red marble is now added to each bag. A second marble is then removed at random from the same bag that the first marble had been removed from. Right. So now, A. Draw a tree diagram to represent this information, showing the probability on each of the branches. So firstly, there are 2 bags. Bag X, bag Y. So probably I will just draw it here. This is bag X, bag Y. Okay, so each bag will be having same probability, half. Now for the bag X, there are 7 red marbles, 3 blue marbles. So red marbles, blue marbles. So 7 out of 10, 3 out of 10. Okay, for the bag Y, we have 4 red, 1 blue. So 4 red, 1 blue, total is 5, so over 5. Okay, now the question says, Freddy chooses one bag. A marble is removed from the bag, then is not replaced. A new red marble is now added to each bag. So which means if let's say I have chosen the red marble here, alright, so here I will get red marble, red, blue. Now from here, from the first branch means that you have chosen red marble from the bag X. Then at the same time, when you add, okay, now added to each bag. So when you add a new red marble, even though you have taken 1 red marble here, supposedly it is reduced by 1. But then since you have added 1 more new red marble, that means it becomes no change. So I will get 7 out of 10 and 3 out of 10. Okay, with the additional 1 red marble. Now, if let's say you have taken the blue marble, but then now it's supposed to be 9 marbles in total now, but because you are adding one new red marble, so obviously it will be 10, but then the blue marble has been reduced by 1, becomes 2, and then the red marble added 1, therefore it is 8. Okay, same explanation goes to the bag Y. So for bag Y, if let's say you have taken 1 red marble, so now, okay, and then you supposedly reduce by 1, but then you have added 1 more, therefore it will remain the same for both probabilities. Okay, and now for the bag Y, if you have removed the blue marble, so it means that no more blue marble in the bag Y. Okay, and now you have added 1 more new red marble, therefore it becomes 1 because it will be all 5 red marbles. So this is the tree diagram for this question. Okay, so now next question. B. Find the probability that both of the marbles removed from the bag are of the same color. So if this is of the same color, go back to the tree diagram. So which means it could be RR, BB from the back X, or RR from the back Y, then BB from the back Y. Right. So I will write here P probability equals to P back X RR or back X BB, both also blue, or back Y RR or back Y BB. Okay, then for the back X or Y, the probability is half. Then now for the RR, just 7 over 7, 7 over 7. So I will write times 7 over 10, not 7 over 7, 7 over 10. Sorry about that. So for the back X is still half, blue, blue, okay, BB here is 3 over 10, and then 2 over 10. So here I will be getting 3 over 10 times 2 over 10. So that's all for the back X. Now back Y, half again. For the RR, it will be 4 over 5, 4 over 5. Plus back Y is half, then both blue. So blue means 1 over 5 times 0. Okay, so here 1 over 5 times 0. Then from here, you will be getting the first one is 49 over 200. The second is 6 over 200. Third is 16 over 50. Then plus 0. So at last, you will be getting 119 over 200. So you can leave your answer in fraction or decimal. It will be 0.595. So that's the probability of parts B. Okay, now C, find the probability that back Y is chosen, given that this is the keyword for conditional probability. The marbles removed are not both the same color. Okay, so P back Y, but not both the same color. That means now since this is conditional probability, our formula is PA/B equals to PA intersects B over PB. Okay, which means you will be getting PY intersect not both the same color over probability of not both the same color. Okay, so this is a definition of the conditional probability. Now, if the numerator Y and not both the same color, that means you will be getting PY RB or PY BR. Okay, they won't be the same color, and then but it must be from the back Y. So then divided by, if not both the same color, means it could be from the back X or back Y. So I consider back X first, XRB plus PXBR plus the numerator YRB plus PYBR. Okay, so now for the YRB, Y is half. So the RB, let's look at the tree diagram. Okay, so now back Y, R, then B. That means 4 over 5 times 1 over 5. Okay, so I erase all this first. So I will have to write 4 over 5 times 1 over 5. Then plus half BR. Why BR? So y BR is 1 over 5 times 1. Over. Okay, XRB, X is half. The RB, 7 over 10 times 3 over 10. Then XBR, X is half. Okay, XBR. Then it will be 3 over 10 times 8 over 10. Okay, together with the two numerators. Then from here, you will be getting 2 over 25 plus 1 over 10 divided by 21 over 200 plus 3 over 25 plus 2 over 25 plus 1 over 10. Okay, then from here, I will be getting 9 over 50 divided by 81 over 200. So at last, it will be 4 over 9. So that's your probability. Okay, so this is your final answer. Right, now for question number 7. A, find the number of different arrangements of the 9 letters in the word. Okay, these are the 9 letters in which no consonant is next to another consonant. So D, M, and R are consonants and A, E, O are not consonants, which means it's the vowel. Okay, so basically here A, N, D, R, O, M, E, D, A, there are 9 letters here. So I will have vowels. There are 4 vowels, A, O, E, A. So here I have 4 vowels. These are the 4, A, O, E, A. And then I have consonants. I have 5 consonants. The consonants will be N, D, R, M, D. Okay, so N, D, R, M, D. So the D is repeating. Alright, so from here basically means that I will have 2A here. Right here I have 2 A's, and then here I have 2 D's. Right, they're repeating. So which means now, okay, you want to make sure that no consonant is next to another consonant. Means that I can just direct arrange the vowels first. So A, O, E, A. Okay, so my number of arrangements, it will be 4 factorial, but the 2A, the A is repeating, so over 2 factorial. Okay, after that, my consonants, since no consonant is next to each other, means that next to another consonant means that you cannot have 2 consonants next to each other. So the only way is your consonant will be the taking the arrow space, right? The arrows slots. So it means that there will be 5 slots for 5 consonants here. So then I will write times 5 factorial. But when you just write 5 factorial, that means you are given 5 different consonants. But now we have 2Ds here, so divide by 2 factorial. Whenever repeating, then you must divide by the factorial. Then this is going to be 720. So we have 720 ways to arrange the 9 letters that satisfy this condition. Okay, now for parts B, find the number of different arrangements if of the 9 letters in which there is an A at each end and the Ds are not together. That means out of the 9 letters, okay, so here basically we have 9 letters, we have 2 A's, 2 D's, and 5 others. Okay, so then now our concern is both ends must be A. Then I have 7 spaces here, 1, 2, 3, 4, 5, 6, 7. Then here is another A. Right, and then it's mentioned that the D are not together. So I can say that here will be 7 letters. Okay, 2 D's are not together. So 2 D's are not together. So you may use many methods. You can just use the easiest method, number of arrangements equals to number of arrangements without restriction. Number of arrangements of 7 letters. Okay, there's 7 letters. But out of the 7 letters, we have 2 D's, right? Without restriction. Then you minus when the 2 D's are together. Minus number of arrangements when 2 D's are together. So when you minus the 2 D's are together means that the 2 D's are not together. So for the first one, right, without restriction means that we just arrange this 7. But out of 7 letters, we have 2 repeating letters, which is a D. And then minus when the 2 D's are together. Okay, so when 2 D's are together, let's say here I group this as 1. So here becomes 1. Then here you have 2, 3, 4, 5, 6. Now becomes arranging 6 letters. So it will be minus 6 factorial. So since these 2D are the same, no need to divide by 2 factorial because we already group them in one group. Therefore, the final answer, okay, here I erase. Therefore, you will be getting 1,800. So this is how I solve this question. Okay, so now 4 letters are selected as random from the 9 letters in the word C. Find the probability that this selection contains at least 1 D and exactly 1 A. So from 9 letters, we have A, we have 4 vowels. I would say we have 4 vowels and 5 consonants. Okay, here we have AA, OE. Then here we have 2 D's and 3 others. Okay, 3 others. So now, when you need to solve this problem, you have to be careful with this. You are counting probability of selection. Okay, so now, from 9, you choose 4. From these 4, at least 1 D and exactly 1A. So which means you may get 1D, 1A, then 2 others. Okay, or you may get 2D, 1A, and 1 others. Right? So from here, the probability of selection. Now, since you are counting probability of selection, okay, so be careful with this. Probability of selection. To get this D, you need to choose one from the 2D, right? So that means it will be 2D, choose one. And you have 2A's here. 2A's here, you also choose 1A. Therefore, I will be getting 2C1, okay, to get the A. So 2C1. And then I need these 2 from others. So which means I still have 3 others together with the O and E, right? Which means here together I will have 5. Okay, so it means that 5 I choose 2. So I will not say others here, right? Other than 0 and the D and A. So it means that from 3 and OE, we need to choose it for the underline. Alright, so that's why here 3 plus 2 is 5. 5 I need to choose 2. That is how I get 5C2 here. Okay, and now this will be the selection, or is plus. Now I need to get 2D from the 2D. Therefore, 2 choose 2, followed by I need to get 1A from 2A's. Therefore, it's 2C1. Okay, and I need 1. So from the green color, so it means that I have 5 choices, but I need 1. Okay, so therefore from here I will be getting all this number of selections over the NS, which is the number of selections without restriction. So in general, right, there will be 9. You choose 4. So that is our denominator, 9C4. So now here I will just write 9C4. Then at last you will be getting 40 plus 10 divided by 126. Okay, so it will be 50 over 126, and at last you will be getting 25 over 63. So that is the probability of selection for this question. Okay, so we have come to the end of the video. Thanks for watching. Please subscribe to the channel and like the video if you enjoy watching the video. Thank you. Bye.